Hello and welcome back. Today we are trying to find out how multiplication is done when we're dealing with equations. And the way we are first of all going to be doing this is by having an equation at hand. So let's say we have the following equation, x is equal to 2, and we're trying to find out how multiplication is going to be done by using this specific equation. Now it's not very different from how we were doing the addition and subtraction, and the way we did that was by, let's say we added 2, but we added 2 on both sides. And if we subtracted 2, we subtracted 2 on both sides. Similarly, when we're doing multiplication, we have to do the same thing. When we're multiplying, we have to multiply the same number on both sides. So we're going to be using the x, the cross, as our multiplication symbol. And so let's say we use the specific number 2 or 3, but if we use 2, we're going to be using the 2 on both sides. Now we can't say that we are going to multiply 2 on the left hand side and 3 on the right hand side. No, we can't do that. That is going to ruin the balance of the equation, and the equation will not hold true at that point. Now, the most important thing is, for example, you choose 2, right? So you're going to choose 2 and multiply it on both sides, okay? And that way you don't ruin the balance of the equation, okay? So 2 times x is equal to 2 times 2. Now let's say you don't want 2, you want 3. Well, you can use 3, but at the same time you have to multiply 3 on both sides. So 3 times x is equal to 2 times 3. And that way the equation holds and it does not affect the equation. And if you want to solve the equation, we can say on the left hand side 3 times x is going to be equal to 3x, and on the right hand side 2 times 3 is going to be equal to 6. And that way the equation holds. And if you actually look closely enough, 3x is equal to 6 is the same equation as x is equal to 2. Nothing has changed. We just have some extra numbers that when we get rid of, we get the same answer, x is equal to 2, and that way you can actually prove that you haven't touched the balance of the equation, and that is why the equality actually holds. So let's actually use the visual approach, the whole scale approach that I wanted to use. And this is actually an old scale, and which was used to measure the weight of certain objects. And on the right hand side we used to put actual weights which we knew were like for example 1 kilo or 2 kilos, and on the left hand side we used to put vegetables or something, which by their equality, by not tilting on either sides and being stable, we can say that both of them have equal weights. This can actually be used as a really good example, as a really good a situation where to understand equations, because equations are literally like this. They have let's actually put some stuff in the scale. Okay, so let's put the mystery box on the left hand side and 2 oranges on the right hand side, and we can actually say that this is in fact equal to this equation. X is equal to 2. Let's say the mystery box is the x and the 2 are the oranges. Because there is 90 degrees over here, we can actually say that the thing is balanced. Okay, so what we actually did over here is put some extra stuff inside the mystery box, and it is still balanced. Okay, we have 2 mystery boxes on the left hand side right now, and we have 4 on the right hand, 4 oranges on the right hand side, and still, as you can see, the thing is balanced, and it isn't tilting to one side or the other side, but it is actually balanced, which tells us that the equation is balanced and the new equation is actually equal to 2x. And on the right hand side we have 2 times 2, which is equal to 4 oranges. So we can actually say that now we have 2 mystery boxes and 4 oranges. Now I really tried to actually use this example because I actually thought that it actually helped me a lot when I was trying to understand the whole equations concept. But actually we can actually use some actual examples. So let's say we have the following example: half x is equal to 3, and we are trying to find x. Now whenever we are trying to find x, we are actually just trying to find out what we are actually trying to isolate the x in such a way, okay, where on the left hand side we just have x, and on the right hand side we have any number, any object or anything, but the x has to be individual. The variable has to be individual. Whatever we're trying to find has to be isolated from the rest. So let's actually try to do this right now. And the way you're going to be removing the half that is in front of the x is by actually multiplying it by 2. Okay? Now when you multiply half x by 2 to remove the half, okay, because you're not trying to ruin the balance of the equation, you're going to multiply 2 on the right hand side as well. This is an example of how multiplication is done in when we're dealing with equations. Okay, so on the left hand side we can cancel out the 2's and we get the answer x. Okay, and on the right hand side you can multiply 3 times 2, which gives us the answer 6, and you can find the value of x. So what does this actually tell us? It tells us that the mystery box that we had previously is equal to 6 oranges. We have mystery box on the left hand side and we have 6 oranges on the right hand side. So let's actually do another example. So another example can be like 1/3 times x is equal to 4. Again, you are told to find out what x is. Now to do that, what you have to do is to isolate the x in such a way that you only have x on the left hand side and you can have anything on the right hand side. So to do that, in our case, what do you do to get rid of the 1/3, which is right besides the x? You can multiply it with 3, and when you multiply it with 3, you can cancel out the 3 that is in the denominator side, because the 3 that we are going to be multiplying it is going to be in the numerator side. So we do that, and because we're not trying to ruin the balance of the equation, we have to multiply the 3 on the right hand side as well. Okay, so that way the equation is balanced, it remains the same, it is still holding to be true. Now we can get rid of the 1/3 over here, and on the right hand side 4 times 3 is going to be equal to 12. So we get the final result equal to x is equal to 12, and this is going to be our answer. Now what does this actually mean? This equation tells us that there is a single mystery box on the left hand on the left hand side, on the left scale, you can say, and on the right hand side we have 12 oranges in this case, and that is all there is to finding out the values of x, but more importantly how to multiply any equation when any number when we're dealing with equations. So thank you for watching, and I really hope you learned something.